I would like to start with a quick poll. So who here uses Maven in their day-to-day work? Raise your hand. Okay. Who uses Gradle on the day-to-day? Okay, I see one raised hand. And who uses SBT on a day-to-day? Okay, so absolute majority for SBT. Cool. So welcome everyone. My name is Natan Silnitsky, and I'm a backend engineer at Wix.com. And I was part of the task force that migrated Wix backend from Maven to Bazel. Now, Bazel, if you don't know, is the build tool created and used by Google, which they open sourced a few years ago. And once we migrated to Bazel at Wix, we dramatically improved the development velocity. You can see here one example for one of our Maven repositories, one of our larger repositories, that on average a build time took locally 45 minutes. With Bazel, it usually is less than 1 minute. A few numbers for Wix backend. We have 250 developers, more than 750 microservices, more than 10 million lines of code, mostly in Scala. There is some legacy Java code and also parts in Node.js, and thousands of builds every day. So we used to be with the Maven and TeamCity, and like I said, locally for many repos, it could take dozens of minutes to get the entire thing built. And on any small infrastructure code change, you will get long queues in TeamCity. And in order to deplete it and get all of the leaves and applications finished building, it could take up to hours to finish. Now with Bazel and Google Cloud, usually it's only a few minutes. So with Maven, there was coarse granularity dependency on the infrastructure, and with Bazel, it's much more fine-grained. So on average, you really only spend a few minutes to get your builds running on even on the lowest level of your dependency graph. So I'm going to talk about how Bazel gives you fast, correct, and scalable builds for your growing code base, and specifically how Bazel allows for faster Scala builds. So one of the key differences between Bazel and SBT is the very high degree of flexibility for what is the smallest build unit that you define. So you can take just one Scala file and define this is what I want to build. Or you can go to the Scala package level. And it can also be a set of packages, but it's really up to you. You define it, and it's a very flexible system that allows you to do basically whatever you want. Now, the basic build unit is called a target, and you define it inside the build configuration. And targets are instances of rules. So what is a rule? A rule is basically a computed function over a set of inputs where you get some output over this set of inputs, usually files that you created. And so with Bazel, you can have many, many different kinds of rules. It can be a Scala library rule, where you will build a jar, or a C++ binary. And you can also run a Python test, or run a shell script, and many, many different kinds of rules. Wix has also created rules that it found was missing, and it needed to add them. So it's a generic tool that allows you to define any rule that you need over this basic concept of executing functions on a dependency graph. Now, the inputs for this function can be naturally any source files or any dependencies that need to be built before that, but also all of the needed tools, configurations, and environment variables. So anything you need to have as input for your rule to get built, you have to define explicitly. And why do you have to define explicitly? Because if it will be some implicit thing that is found on your machine, then if you run it with Bazel, it will fail, because Bazel will run your rules in a sandbox environment, and that means that it will have very explicit strictness on only the things that you declare in the build configuration, which can be quite verbose. Only those inputs that you declare are part of it. Anything else will not be part, and then you'll get a build failure. But what this allows us is to have deterministic reproducible builds. So on the same set of inputs that you defined, you will always get the same outputs, no matter when you run it. So that's a guarantee Bazel delivers. So we talked about having any kind of granularity that you want, and that means that you probably tend to try and get smaller and smaller build unit granularity for your targets, which will give you a lot of advantages. First thing is building one target will be faster, and the impact of changing this small target will be much lower than something that has coarser grain. But the downside of this is that you will get many target definitions of the inputs and attributes that you need for this rule to run, and you need to maintain it. So there's a lot of overhead here. It's going to be much more verbose build configurations, and we'll see how this can be mitigated. So if we have much smaller build unit granularity or targets, that means that a lot of them don't even depend on one another, and you can run them in parallel, unlike with SBT that you will most likely have a coarser grain and a lesser degree of parallelism. And furthermore, not only will you get a compilation building running parallelism, it will also be able to run the tests simultaneously as it runs compilations. So here you can see the blue targets are already running tests, while some of their dependents are now finishing up compilation at the same time. So Bazel will utilize as many cores on your machine as it can in order to get the highest degree of parallelism and as fast builds as possible. And of course, it will keep all of the hashes of the outputs inside your local cache, which means that you will only need, on any small change you do, you will only need to rebuild that small part of your graph. And not only that, it won't need to recompile your test code. That means that it will find that most of the tests don't need to get rerun because the source for them hasn't changed. So when you do Bazel test, it will also be quite fast, and only the relevant tests will be run. Now, a very powerful concept in the Bazel world that's also getting to other large codebase build tools is called remote execution. And that means that, okay, you're limited on your local machine with the amount of cores that you have to run stuff in parallel, right? So Bazel came up with a remote execution protocol where you send the build targets execution, the actions, to a remote worker pool. So each of these actions will be run on a separate worker. Now, there are open source solutions out there that let you configure this farm yourself, and also Google provides a solution on its own that we at Wix are using. And we actually utilize hundreds and hundreds of these workers in the cloud to get the maximum amount of parallelism that we can, which means, of course, much higher, much faster build times. Now, not only that, these action outputs are all saved in the remote cache, which means that when you send consecutive build commands in your CI server, they will be able to reuse these results and not need to rerun most of the things. And that is, of course, very powerful. And up until this point at Wix, we have yet found the need to clean any of the cached results because of all of the characteristics I mentioned before. We can rely on the build output and always have this incremental build remotely. And you can also utilize this remote cache on your local machine. Not only that, you can also send from your local laptop, send these build actions towards the farm on the cloud. And of course, here you get the trade-off between faster compilation and test running because of the high degree of parallelism, but you also have the network latency to sending these actions and getting back the outputs. There is an experimental feature in Bazel which dynamically runs both the action locally and remotely, and it will stop the slower action once the faster action completes. So then you can enjoy both worlds, but it's still in experimental stage. So that's about remote execution. And to see a few numbers about what we witness in Wix repositories. So like I mentioned, if you ran in the past one of our repositories with Maven without any pre-defined cache, so it takes 45 minutes. And with the same clean cache for Bazel, it already reduced to 20 minutes on your local laptop because of the higher degree of parallelism. Now, if you send all of this work to the remote build farm of workers, then, and you tell it, don't use the cache, there's a flag that you say, don't use any cache, you already reduce it to 8.5 minutes. And of course, if you run it again later, Bazel will only need a few seconds to understand that nothing has changed and you can complete the build. Now, I won't lie to you and say that it's easy to use Bazel. John previously talked about he wants fewer configurations as possible. In Bazel, it's quite the opposite. There are a ton of configurations. So if you're a small startup just starting up and you want out-of-the-box solution, I wouldn't recommend going with Bazel, because you get a steeper learning curve and you need to change your code to adhere to the sandboxing principles, and especially for test running. So you get some overhead. But as your code becomes more complex, bigger, more interdependencies, and you start getting slower build times locally and on your CI solution, I think it's really worth considering because it can really accelerate your builds, and you won't get to a situation where your development velocity is hurt. Okay, so that was a quick recap of the Bazel features. Now, Bazel comes out of the box with support for Java and C++, but it also, of course, allows to write plugins for any type of language that you want. So that's again a different concept than Fury has. So specifically, there's a plugin for Scala that is open source, and all of these rules for all of these languages are contributed by the open source community. And specifically for Rule Scala, the maintainers are Stripe and Wix. And it's written in Scala and in Starlark. Starlark is the extension language that you use for Bazel. It's a subset of Python, and it's not Turing complete. So John mentioned also that with build definitions and dependency graphs, you don't need an entire language, but it does help give you all kinds of constructs and access to the information that you need in order to define your rule. And yeah, so that's Rule Scala. It's already used by many companies other than Stripe and Wix, also Etsy and Spotify and meetup.com and others. So unlike SBT, where you get a convention-based approach of it knows where to find all of your source production code and test code, with Bazel, you put the build definition next to your code, and all of the targets definition is found in the packages themselves. We'll see an example shortly. And now I want to describe a few basic rules that Rule Scala provides. So the first one, quite naturally, is Scala library, which basically means that you can pretty much see for yourself. You get the source file inputs and other dependencies, and the function is actually invoking the Scala compiler, and the output for this rule will be a jar that you can consume by other targets. So here we can see an example. We have a target that's being built. It's called A. It has as source only one file, one Scala file, a.scala, but it also depends on target C, which in turn only has a source one Scala file, which is c.scala. It will output an a.jar, and you can execute this target by calling Bazel build and :a if you're in the working directory of this package. So the second basic rule here is Scala binary, right? You can here again compile the source files and get other transitive dependencies, but unlike Scala library, other than outputting a jar, it will also output a shell script, and the shell script will define a command to run main class on the JVM. And your main class will be one of the arguments. So you can see here the Scala binary target is called B, and there's also an attribute here with the main class. And in order to run it, you use Bazel run, and because it's state run, then it will look for the executable shell script and will execute your Scala application. And lastly, on the basic rules is Scala test. So quite naturally, it will compile your test files into a jar. And very similarly to the Scala binary, it takes the shell script, and instead of your main class, it will invoke the Scala test runner. So this is an example of a build definition for a Scala test rule. And here you can see that it takes a wildcard all of the source files in this package that have a suffix with test in it. And to run it, you just call Bazel test, and it will also again run this executable and run your jars, run your test through the Scala test runner. So let's see a quick demo here. I'm using VS Code, but there are plugins for IntelliJ, for Eclipse with Bazel, so you can use whichever IDE you prefer. There's no plugin for Vim yet, I think, John. So it's a really simple Scala project, just addition, multiplication. So the build files here are pretty simple. And the tests just refer to they depend on the production code. Here you can see the full path that it needs to provide in order to get to the correct target. So in order to run all the tests in this repository, I just type Bazel tests // ... and you will get all of the tests that it will analyze and find all of the tests that are defined in this repository. And you can see here that I already ran it before, so it found out that it doesn't need to run anything because it's already cached. So it was really, really fast, but we can change test and make it fail and run it. You can run it from this plugin here. Okay, so it's compiling the source file that was changed. Can anyone see? Want me to increase the? Okay, good. Okay, so it took 1.1 seconds to run the tests, and it failed. So let's fix the test failure and run Bazel test again. So it recompiles and reruns the tests that I changed. And you can see again, it only ran the tests that was changed, and it mentions that the other test that I didn't touch is cached. Okay, so that's a simple demonstration of the Bazel features in action. Now, other than these three basic rules, you can have many more rules that you can use from Rule Scala. There's JUnit support, Specs2 support that Wix actually wrote and added. There's Thrift and Proto library support, like automatic code generators, and there are more. And you can add your own if you see anything that is missing. So there is you need to learn Starlark in order to write it, but and it's very similar to Python. And once you get the hang of it, it's pretty straightforward to add additional rules. And we at Wix added several. Okay, so that was the basic possibilities you have with Rule Scala. Let's look a little bit on deeper level on what the included features that Rule Scala has. So the first one is, the first important thing to mention is that Rule Scala is battle tested. It has an extensive end-to-end suite where all of the regressions are inside and that they verify everything. So it's production tested. And more importantly, it verifies the basic reproducibility that Bazel guarantees. So how does it do that? It just takes its own set of building targets, and it builds them with a delay between different executions of this build, and it just makes sure that the outputs remain the same even though the time has passed, and so there's no non-determinism inside the rules themselves. So when you use them, you can rely on them that you will have reproducibility, and you won't need to clean your cache. And that's exactly what we experienced at Wix. But we didn't need to run any clean command up until this point. Now, language interop. So like there's rules for Scala, and I mentioned support for Java out of the box with Bazel. There are also rules for Groovy and rules for Kotlin. And you can have all of these languages inside your repository and interact between them and have a Scala target depend on a Kotlin target. And the way this is done is by all of these JVM rules have a convention that they provide as output a Java info common structure. And that means that there can be simple interoperability between them, and it just works. So that's about language interop. And dependency management is a very important point here, because we have much more verbose build files and many more build files compared with SBT and other build tools. So what you want is to have as much automatic fixing and creation of these build files as possible, including all of the dependencies that can change quite rapidly because they mirror more closely the source files themselves. So one feature here is unused dependencies. It just scans the build definitions when you compile, and it sees which dependencies are no longer needed by your source files, and it will warn you or emit an error when you longer need them. And there's a bulldozer command that actually executes any changes to your build files through command line. And you can also, we have scripts that can run them continuously and watch. There's iBazel that you can watch and run these bulldozer commands automatically. Another important concept is, other than the unused deps, is strict deps. So strict deps means that if, say I have a library called foo, and it depends on specs2 and in the code, and the code also depends on cats, the build definition also has to specify that there is a direct dependency on cats. And why is that important? If specs2 decides to stop using cats, your build will not break, and you will get much more explicitness. So Bazel really favors explicitness and more reasoning about what do I really depend on in order to get better and more hygienic build definitions. Because it's more explicit, it means you have a more preferable guarantees of incremental builds. And both unused dependencies and strict dependencies are based on the class path shrinker plugin from Jason Zog. It just understands which jars the Scala compiler loads when it's compiling, and then it compares it to the dependencies found in your target definition. Now, but this doesn't go further enough to have the developer, the user, to have you not going to the build files and fixing them all the time. When you add some import, I'm going to need to add a dependency. So what we in Wix are working on is a tool called Dep Fixer. This is outside Rule Scala, and we hope to open source it soon. And this one, if you say you have one repo that you're working on, it will index all of your jars when you compile, and it will scan your build log and find all the Scala compiler errors, and it will just match, find any of these symbols missing inside of the jars that it indexed, and it will just add the dependency to your build files, and without you needing to do anything. It's already being used by several teams at Wix, and quite happy with it. If you have several repos that interdepend one another, then you need an indexing server which will index all of your jars from all of your repositories, and you need to then query in order to find where is this symbol resides. And so that's what we have at Wix. We have an indexing server because we have a many repo environment. And So we really hope that this solves the maintenance and overhead issue with Bazel. And this specifically is inspired by Pants, which has a similar feature. And Pants is a similar build tool to Bazel from Twitter. Now, a very important performance feature with Rule Scala is the utilization of Bazel's persistent workers. So we have very small build unit targets that we run the compilation actions on. And if you do it naively, that means that each time we need to start up a JVM and initialize the Scala compiler before we actually start compiling. So this means that we'll get a performance penalty. And with persistent workers, you get a preheated Scala compiler. So as the build graph slowly gets built, more and more Scala compiler instances are running, and you can get much faster compilation time. Now, there is an alternative Rule Scala out there in the wild called Rule Scala Annex from Higher Kindness organization. And they utilize inside their persistent workers Zinc. I'm sure you're all familiar with Zinc. It's a stateful incremental compiler used by SBT and Bloop that John mentioned in his talk. Now, the official, and Zinc has caching on the class level. So what Rule Scala Annex gives you is not only caching on the build targets level, but also a more even more fine-grained caching solution for your Scala class files, which actually covers you completely in terms of caching. It's not part of the official Rule Scala in a Bazel build organization because it is stateful, and Bazel does not espouse to have any statefulness inside of the build tools because it may lead to cache poisoning, and that's something that Bazel really tries to avoid, so you won't need to clean your build caches. So let's see a quick demo of running with and without the persistent workers. What I have here are two identical instances of the Rule Scala repository itself, which I've already, oh sorry, I ran the incorrect strip, just a second. I have a backup just for these cases. Okay, so no, it's called build test, right? So these are two identical copies of Rule Scala that I've already preheated. You can see the script here. I did Bazel clean expunge, and then I build all of the Scala source files here. And because I didn't want us to wait for only protobuf generation of Scala files and all kinds of stuff. So what I'm running here is Bazel build. We're building all the test sources. And you can see that it's running 8 actions because I have 8 cores on my machine. So it utilizes all of the cores because it really wants to get a higher degree of parallelism. And it's actually not preheated. So it's actually ran the tests themselves. Right. Okay. So it's going to finish soon. And yeah, so now you can see that it's running the actual Scala test targets themselves. It's running them in parallel. And okay, so I'll stop this now. And you can see here when I'll have persistent workers in the command line. You can see here running the same test target, only this time with the strategy of Scala C worker, which will actually invoke the persistent Scala compiler workers. And you can see that it's running the build actions for these test source files much faster. And I can tell you that here it took 1 minute and 3 seconds usually to compile these test classes. And here it's going to finish, okay, 43. I saw 30 seconds before, but you can imagine that having preheated Scala C compilers and JVM instances is important for your build files. Okay, so Ur Scala, like I mentioned, is open source. This is the GitHub link, and I encourage you to try it out. If you're interested in getting more information on Bazel, you can see in more in-depth how can you get a successful migration to Bazel, and what does it entail in terms of your amount of repositories, in terms of choosing the right build granularity. There's a talk from Devox which you can watch, and also I have a blog series on this. Another very interesting blog post is by Databricks. They have a monorepo which a Scala monorepo, which they moved from SBT to Bazel and did all kinds of nice tricks. And I really recommend reading this blog post. So to summarize, Bazel is worth it. You'll get faster builds. The ecosystem is becoming better. We have a team at Wix that is contributing to the IntelliJ Bazel plugin to make it better and better for our developers and everyone else using it worldwide. And I mentioned Dep Fixer. So the ecosystem really improves day by day. And Rule Scala is mature and battle tested, and you can use it safely. So thank you very much. And if there are any questions? Yeah. I think he's bringing a microphone.
Thanks for the talk. Really nice designs as well. Is there a way to get the best of both worlds? So it seems like SBT is a bit less verbose config-wise. Fury is even less verbose, but basically it's much faster. Can we get the best of both worlds? No configuration and really fast compile times?
So no configuration, I think you need to use Fury. But I think the whole premise of Bazel is the explicitness. So I think with Bazel, you always get this verbosity. I think the approach would be, how do I get the tooling to do the job? Google has tons of tools internally, but they don't open source everything. So we're trying at Wix to do the catch up on that, so hopefully open source it. And you can use Zinc from SBT world, like you use in Rule Scala Annex. So maybe that's getting the best of both worlds in terms of caching, at least.
Cool.
Okay, so you can see, you can get the slides from this talk and the links on SlideShare, and follow me on Medium or Twitter to get more updates on Bazel at Wix and what we're up to. Thank you again.